Welcome to the part of our discussion about FET, which is the MOSFET. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. MOSFET has two channels, which are the N channel and the P channel. For the N channel, it is a P-type semiconductor doped with two N-type semiconductors, while for the P channel, it is an N-type semiconductor doped with two P-type semiconductor. And this MOSFET has two types, which are the depletion type and enhancement type. First, we will discuss about the depletion type of MOSFET. For the N-channel depletion type MOSFET, it has these following parts. Like the JFET, we have the drain, which the electron goes out, and the source, and we have the gate, which controls the flow of electron. However, there is a dielectric inserted between the gate and the P-type semiconductor, which we call the silicon oxide. So how this N-channel depletion type MOSFET works? Basically, N-channel has a majority charge of negative, while the P-type semiconductor has a majority carrier of positive. So if you're going to put a negative charge on this gate, basically there is already a channel connecting between the two N-type semiconductor, which is also connected to both the drain and the source. So there is still an electron flow acting on this channel. But when we put the a positive charge on the gate, there is an enhancement mode that could act on the MOSFET. Basically, through the law of attraction, which states that the opposite charges attracts and the like charges repel. Basically, on this P-type semiconductor, there is a presence of both the majority and the minor and the major carrier, and applying a positive charge on the gate, all the or some of the minority carrier on the P-type semiconductor will go to the N channel, and some of the positive charge, or let us say the holes on the P-type, will repel. So it can be seen on the graph that as the VGS, or the voltage acting on both the gate and the source, becomes more positive, the saturation level of the current acting on the drain also increases. But when we apply a negative charge on the gate, there is what we call a recombination process of both the P material the holes and the electrons, and there is still an electron flow on it. Let's go for the P-channel MOSFET. So this P-channel MOSFET has the same principle as of the N-channel MOSFET. However, there is a polarity shift on the gate, which could result to the same graph of the ID versus of the VDS, or the voltage acting on the drain and the source, versus the current acting on the drain. Now let's go to the enhancement type and channel MOSFET. As what we have seen at the depletion type N-channel MOSFET, there is already connecting N channel between these two doped N-type semiconductor, which is connected to both drain and the source. But for this enhancement type N-channel MOSFET, there is no channel being connected. However, also the parts are the same. So how does this work? Basically, if we apply since of course as what we know, N-type semiconductor has a majority carrier of a negative charge. So if we apply a positive charge on the gate, it will attract the negative or the minority carrier of the P-type semiconductor, and it will create a channel. And that's the thing, or that's the time that the electrons will flow. Thus, as we increase the negative voltage on the gate, sooner or later it will create a pinch off beginning, and therefore there is no electron flow, or if we're going to see it on the graph, it became only it goes into the saturation level acting on the circuit. It can be seen on the graph. It can be seen on the graph that as the VGS, or the voltage between the gate and the source, increases, the saturation level of the current acting on the drain also increases. And lastly, we have the P-channel enhancement MOSFET. Of course, it still has the same principle as to the N-channel enhancement MOSFET. However, the polarity on the gate will also be reversed. So that's all about the MOSFET. Thank you.